All right, class, welcome to chapter 5, where we will be concentrating on radical and rational functions. So we are following the same kind of, methods, if you want to call it, where we first discuss how to solve those types of equations, like we started with linear equations in one variable. Then we moved on to the functions, applications and such, even inequalities. We did the same thing for absolute value, quadratic, polynomial. So moving through all those basic functions that we discussed in chapter 1, that list of toolkit functions I've given you. So we're finally coming up and finishing up that list with the radical and rational functions in this chapter. And so first, let's look at solving radical and rational equations in one variable, of course. So it's more of a review from lower algebra classes. And here it is. Now, of course, radical equations will have some radical symbol. Rational equation, the ratio is really a fraction, right? So a rational equation is one that involves a bunch of fractions, okay? So how would we solve these equations? Well, I'll let you read this on your own, but the idea is you want to undo what's been done. So just to give you an idea, we looked at solving quadratic equations in the last chapter by using the square root property. So in other words, we undid the square with the square root. So we ended up with the square root of 25 is 5, but of course we also wanted the negative square root of 25 as a choice, and that gave us the negative 5 answer. So what we are doing in this chapter now is we need to undo the square root. So squaring and square rooting are what we would call inverse operations. They undo each other. Same as we undoing an addition with a subtraction, a multiplication with a division, and backwards a division with a multiplication. We will be undoing a square root with a square. So same as we did with those absolute value equations, before we even get rid of the absolute value or get rid of the square root, you want to isolate the radical expression on one side. So if it's not isolated, we'll do that first. So number 1, and yes, I see the radical is by itself. It's a square root, so therefore I'm going to square both sides of the equation. So again, the square is here just to take away the square root symbol. And then 5 squared means 5 times 5, and that's 25. And after we got rid of the square root symbol, as you see, it's a simple linear equation that we've already learned how to solve. Divide, again, undo the addition with a subtraction, just like we discussed earlier, undo a multiplication with a division. So therefore, x is equal to 7. We'll do the same thing, but again, remember, first thing you want to do is isolate the radical. You do not square yet. So we'll get that the square root of 10x plus 1 is equal to 12. And now that the square root is by itself, we're going to square both sides. So again, the square is there to take away the square root symbol. And then again, finish solving this as you would with a linear equation. In other words, minus the 1, divide by 10. Of course, you can write 143 over 10 just the same. You don't have to turn into a decimal, but either one of these is correct. Let's do this again. I'm going to minus the 8. So I have the square root of 10x plus 1. This time is equal to negative 5. So we should be stopping right here and recognizing that this equation is just not going to work. This symbol here, let me put this on for you, is called the positive square root of a number. Now, of course, we don't actually say the word positive because we just got lazy and we just say the square root. However, by definition, this symbol is called the positive square root. Anytime you put this symbol in your calculator, square root of 9, square root of 25, square root of 16, every time you get a positive number because that's what it does. This is why when we write these equations, we put the plus or minus because the plus gives me the positive square root of the number 25. The minus, see how it's outside? So the minus positive square root of 25 is minus 5. So this piece alone here gives you always a positive number. And as such, it could never equal to a negative. So the positive square root of a number, unless it had an extra minus at the front. So if it had an extra minus at the front, then yes, of course, it has to come out negative. But it doesn't, yes? So let's say you didn't notice this and you kept going and you went on and squared both sides. And again, remember, you square the whole negative 5. So fine, you get 10x plus 1 equals to 25 minus the 1. Divide by 10 and you get 2.4 and you're happy as can be. However, one other big part which we haven't actually done because I knew we had the correct answers. One big part of solving radical equations is confirm the solutions by substituting back into the original equation. In other words, check your answer. So even though, okay, I'll try again. Even though we might have done everything correctly, which we did here, we might still end up with something we call extraneous solutions. So let's go back and check our answer right here. Is the square root of 10 times 2.4 plus 1 and then plus 8 equaling to 3? Well, let's see. 10 times 2.4 is 24, and 24 plus 1, of course, is 25. And the square root of 25 is 5. So do you think that 5 plus 8 equal to 3? No, it doesn't. Okay. And we've done nothing wrong. And it's really, even when the 8 over to the other side is the square root of 25 equaling to negative 5. If you look at this version of the equation, the one before you even squared both sides. So no, they're not equal to each other. The square root of 25 is 5 and not negative 5. Yes. So even if you solve everything correctly, you can end up with wrong answers. So this equation, it actually failed right here when your positive square root was equaling to a negative number. So our answer for this equation is no solution. Now, if you check all the others, here I didn't really, but is the square root of 3 times 7 is 21. Plus 4 equal to 5? Yes, the square root of 25 is 5. Yes. If you plug in 14.3, is the square root of 10 times 14.3 is 143 plus 1 minus 5 equal to 7. When you check this, 144, 12 is 12. The square root of 144 is 12 minus 5 is 7. So I'm making a mess. I didn't really needed to check. I know these equations didn't fail because at no point in time did you have a negative number across from the positive square root, right? Like there. Okay. All right, so, okay, that's how we solve square root equations. Isolate the radical, square both sides. Now, radicals are not just square roots, they're cube roots, fourth roots, and so on and so on. So for a cube root, if you remember, a cube root can both hold positive and negative numbers inside, and therefore can equal to positives or negatives. So I'll remind you of the graphs of the radical of the cube root function and the square root function from chapter 1. You can't look them up yourself, but again, here one more time, square root function looks like what? X has to be positive, y has to be positive. However, the cube root function, if you remember from chapter 1, can be both positive and negative, both for x's and for y's, yes? So it's negative y's, positive x's, negative x's. So with odd roots, you are in no trouble whatsoever. With even roots, yes, you are. Okay, so to get rid of a cube root, we will cube both sides. That's the opposite operation, or the inverse operation, I should say. So cubing a cube root makes it go away. And then again, once we get rid of this radical, we end up with a perfectly fine linear equation. Same thing here. First, isolate the radical. And remember, it's totally okay to have negative numbers equaling to odd roots. You can have negative numbers inside odd roots, and they can equal, therefore, to negative numbers. So even once you check your answer, that's fine. Go ahead and check your answer. You'll see it works every time. So again, the cube is here to take away the cube root. I'm left with 5x plus 1, and negative 12 to the third power should be a humongous number. I put in my calculator. Well, not that humongous, but negative 1,728. Okay, no problem. Minus the 1 away. And then divide by 5. So whatever answer you get, you can even leave it as a fraction. It's totally fine. You can give me a decimal. Negative 345.8 is what I got. Okay. So there we're coming up again. This time it's a fourth root, so be careful. Even roots cannot have negative numbers inside the root and cannot equal to negative numbers. So you might be immediately saying, this can't happen, but it's not the root that equals to the negative. There's some work to be done. You have to isolate the radical first, and then you see what you're comparing it to. So when I add 3, first of all, to both sides of the equal, I'm going to get that my 2 times the fourth root of x plus 15 equals to a positive 2, which is totally fine, okay? Moreover, this 2 is on the outside multiplied to my radical, so I'm going to divide both sides by 2, and I'm going to end up with the fourth root of x plus 15 equaling to 1, which is totally fine because it's a positive number. All right, and now to get rid of a fourth root, we're raising both sides to the fourth power. So if you want to get rid of a sixth root, you raise it to the sixth power, and so on and so on. So that's going to go away, and you're left with x plus 15 equaling to 1, which makes x equal to negative 14. And if you check your answer, it completely works. Here, I'll check it for you, just for fun. Is 2 times the fourth root of negative 14 plus 15 minus 3 on the outside going to equal to negative 1? Well, let's see. That's a 2 times the fourth root of Negative 14 plus 15 is a positive 1. And the fourth root of 1 is 1. So 2, that's 2. 2 minus 3 equals to negative 1. So yeah, correct. So I like this answer. It works. All right, these last two I'm giving you here are a little trickier because these are easy. As soon as we get rid of the square root, cube root, fourth root, as you saw, we ended up with linear equation of degree 1, which we definitely practiced and know how to solve. These last two equations here are going to be trickier because as soon as I, yes, red, okay, square both sides, as you see, my square root is isolated. It's all by itself. Yes. So square both sides. The square again takes the square root away, and I know it's a square root because there's no index, we call this, written there. So if no number is written in here, then that means a square root. So the square takes away the square root. However, on the other side, I don't have a number this time. I have an x, and I'm supposed to square the x, okay? So as you see, we now have a quadratic equation and not a linear equation anymore, okay? Now, how do we solve quadratic equations? Well, we've learned in our chapter 3, not long ago, that to solve a quadratic equation, what you want to do is move all terms to one side of the equal. It has to equal to 0. And once you have all terms to one side, once it equals to 0, you're going to try and factor if you can. If not, you can use the quadratic formula. So numbers that multiply to 8 and subtract to be 2 are 4 and 2, a positive 4 and a negative 2. Okay. And we've done plenty of these recently. My two answers are x is 2 and x is negative 4. You absolutely have to check these. Many times once you end up with two solutions, because you end up with a quadratic equation, one of them is not going to work. It's not a rule. They both could fail or they both could work. But the majority of time, one will work and one will not. Okay, so immediately I can tell you negative 4 is not going to work. Why not? Because this negative 4 puts a negative number across from a positive square root. And you can keep going. That's a positive 8 plus 8. Is the square root of 16 equal to negative 4? No, the square root of 16 is equal to positive 4. Okay, so that's not going to work. Now, if you try 2, is the square root of negative 2 times 2 plus 8 equaling to 2. So again, in this equation, wherever I see x, I'm putting a 2. And that's the square root of negative 4 plus 8, which is a positive 4. Is the square root of 4 equaling to 2? Yes, it does. So this one works. Okay. All right. Let's try this again. Same thing, make sure your radical is isolated before you square both sides. And be very careful, on the right-hand side, you have two terms that we need to square. So, the square just takes away the square root symbol. That's why we squared both sides. Now on the right-hand side, I'm going to write this out. To square x, because most students will get this wrong over and over again. To square a binomial, I don't know what I just did, but I might have erased something important. There you go. To square a binomial, or again, two terms, you multiply it to itself. So let's see what we're going to get. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. So that's going to be an x squared minus 4x and plus 4. Okay. Now, most students will just go and just square each one of these terms. That's absolutely not a rule. You're not allowed to do that because, as you see, you do not end up with just an x squared and a positive 4. You end up with a middle term. So that's, again, why it's such a common mistake. First, because students will want to just distribute that squared to this difference. You can't. Okay. It's not correct. So again, I end up with a quadratic equation. Therefore, I'm going to move all terms to one side. So I'll get x squared minus 12x and plus 27. All right. So let's think of numbers that multiply to 27 and add up to be 12, and they're easily 9 and 3. Now much multiplies to 27. So my two answers are going to be x equals to 9 and x equals to 3. You have to check absolutely both of them. So is the square root of 8 times 9 minus 23 going to equal to 9 minus 2? That looks promising because I end up with a positive number across. And that's 72 minus 23, which is 49. So yes, the square root of 49 is 7. So that's an okay answer. And here when you check 3, is the square root of 8 times 3 minus 23 equaling to 3 minus 2. So again, this looks promising as well because you see a positive number across from, again, that's 24 minus 23 is 1, and the square root of 1 is 1. So both these answers are okay this time. Okay. All right, so that's how radical equations work for you. First of all, isolate the radical, get the radical by itself, whether it's a square root or a cube root or any other root, get that root by itself and raise it to whatever power the index of the radical says. So if it's cube, then cube both sides. If it's square root, then square both sides. Okay, rational equations are equations with fractions. Okay, and so we need to find a way to undo those fractions. So as you see here, when you to undo a square root, we square both sides. Yes, to undo an addition, you subtract. To undo a multiplication, you divide. To undo a fraction, which is a division problem, you must multiply. Okay. So what do we multiply by? We multiply both sides of the equation by the least common denominator of all the fractions involved. So let's see what will be a least common denominator of all the fractions involved. So many times, look for 8, x, and 4. A least common denominator is the smallest multiple. So it has to be a number that can be divided by 8, can be divided by x, and can be divided by 4. And because 8 can be divided by 4 already, then that's all there is. So I'm going to multiply both sides by 8 and x. Now what I mean by both sides, I mean every single term on both sides. So I can even write this out next to each one of these fractions. And the reason why I put this higher up, the 8x, it's because it's over 1. So if that helps, you may write it. In other words, it's 8x over 1, 8x over 1. So therefore, it's going to get reduced with any denominator and multiplied to the numerators. So the 8 takes away the 8 in the denominator, leaving you with an x and a 3 behind. For the next fraction, the x takes away the x, leaving you with an 8 times 2 behind, which makes it 16. The 8 takes away the 4, divides by 4, and leaves you with a 2 times 1 times x, which is a 2x. So as you see, with all of this, we cleared all the fractions. There are no more fractions around. I end up with a very nice linear equation. So there it is. 2x minus 3x is negative 1x. And when you divide both sides by negative 1, you get the x equals to negative 16. Now, so there is also something to be careful about, which we're going to come across later. Because the original equation says may have variables in the denominator, remember, you are never allowed to divide by 0. So we must be careful that we don't end up with a solution that would make a denominator equal to 0. So before we even begin solving a rational equation, it says, we examine it first to find the values that would make any denominator equal to 0. You don't really need to do that. Again, I've copied this from your textbook. You just need to look at the end, really. Does negative 16 make any denominator equal to 0? No, the only denominator that could vary is the x, and so really the only thing that would make that x 0 is 0. So don't worry about negative 16. That's not going to make that x a 0, so we're good. All right, what's the LCD here? Is an x to the power of 2. So remember, the LCD is a multiple, something bigger than all your denominators. They could be divided evenly by all your denominators. So I multiply everything by x squared. So again, let me take it nice and slow and multiply it to each one of these fractions. And again, purposefully, I put these x squareds higher up so that you understand that they are over 1. Yes, and therefore they get to reduce denominators and multiply two numerators. So x squared times 1 is just x squared. This x squared divides one x factors out, leaving you with one more x factor, so negative 7x. And this x squared completely takes away the x squared, leaving you with negative 6. So as you see, we end up having a quadratic equation. Therefore, I move all terms to one side of the equal and then see if I can factor it. And of course I can. And the two solutions here are x equals to 6 and x equals to 1. And neither one of these will make your denominators equal to 0. The only thing that can make those x's equal to 0 is x equals to 0. Okay. All right, so here it is. Next equation. This LCD here is simply the 3x minus 2 that the first fraction has, and then the 4x that the second fraction has. So all these quantities in the denominators have to be factors. Okay. So the 3x minus 2 takes away the 3x minus 2, leaving me with 4x times 5. The 4x goes away with 4x, leaving me with 7 and 3x minus 2. So as you see, we end up again with a very nice linear equation, distribute. If you remember, maybe from other algebra classes, what you were given here, just wanted you to also to see it from this point of view. What you are given there is something that we call a proportion, when two fractions equal to each other. So what you have learned in other algebra classes prior to this might be that whenever you solve proportion, you simply cross multiply. So that's exactly what ended up happening. 5 you multiply to 4x, and 7 you multiply to 3x minus 2. But you can only do that if you have two fractions equaling to each other, right? If it looks like this. But if you have more things, plus, plus, minus, you can't do that. Okay. And this is actually the only equation that I have here for you that looks like a proportion. So just two fractions equaling to each other. So x equals to 14 is your answer. And again, 4 times 14 is not 0. 3 times 14 minus 2 is not 0. So this is a perfectly okay answer. I have just a few more for you. They're getting a little bit trickier. To find the LCD here, least common denominator, I'd like to see the factors. So in this case, what we want to do is factor all these denominators. Now, x plus 4 cannot be factored. X minus 4 cannot be factored. But definitely x squared minus 16 factors into an x plus 4 and an x minus 4. So again, we put all those factoring skills to good use over and over again. So that's going to happen every time, even with these last questions. This trinomial thing here is going to factor into the two factors you have on the bottom. Same thing here. We are not going to give you a million different factors, okay? It's just a couple. So therefore, the LCD, as you see, the factors that you need to knock out all these denominators are just x minus 4 and x plus 4. Okay. Now, of course, on the right-hand side, x minus 4 and x plus 4 completely knock both those factors in the denominator away, leaving you with just 8. Here, if you think about it, the first fraction, the x plus 4 is gone, leaving you with a 3 and an x minus 4. Plus, when you multiply it to the second fraction, the x minus 4 is gone, leaving you with a 7 you had and the x plus 4. So every time, really, when you pay attention to these fractions, what you see is that you are getting extra the one factor your fraction didn't have. So the x minus 4 is gone, therefore the x plus 4 comes in its place. That's what ends up happening. So again, if you look at this equation, is one that we have dealt with this semester, which is always a good thing that we keep going back to problems we have solved. And again, that this is the progression through which we go through these topics so that as you see them over and over again, you keep using them over and over again. And we already know how to solve these linear equations, right? That's what this is, a linear equation. So distribute, combine like terms, get the x's to one side, and the constants to the other, and at the end divide. So negative 0.8. And again, check. Negative 0.8 plus 4 won't be 0. Negative 0.8 minus 4 won't be 0. And definitely when you square it, minus 16, it won't be 0. So that's a good answer. All right, we'll do this again. Same thing, be careful. You do want to make sure, again, first of all, factor your denominators. And your denominators will factor X minus 6 doesn't factor. X plus 1 doesn't factor. So it's one single factor. It goes together. But x squared minus 5x minus 6 factors into an x minus 6, x plus 1. Okay, so this will be your LCD. In other words, this is what you will multiply both sides by. So I'm multiplying both sides by x minus 6 and x plus 1. All right, so on the right-hand side, they both go away. On the left-hand side, I'm going to end up with a negative 2x minus 7 times an extra x plus 1. And then minus 4 times the x minus 6. And then again, equals to 2. Right? So one factor at a time is gone, leaving you with the other factor. So I have to distribute. I'm going to tell you I'm going to end up with a quadratic equation, and here it is. The x squared minus 2x minus 7x minus 7 minus 4x and plus 24 equals to 2. So again, combine like terms as much as you can. So that's going to be a negative 13x. Minus the 2 also over, because I want it equal to 0. So I have negative 7 minus 2 plus 24. So that's 15. Yeah. All right. I do not like to start with a negative, so I'm going to factor out the minus sign. And then let's see if we can factor again. 2x and x for 2x squared. I definitely need to get a big 13 in the middle, so I'm going to go for factors of 15 being 15 and 1. And one should be a positive and one should be a negative. So I think, yeah, that's going to be a 15x. Minus 2x, that gives me the 13x in the middle that I want. Okay. So what are my two possible answers? Either x is equal to 1, which is actually fine, or 2x plus 15 equals to 0, which makes x a negative 15 halves. Both of these are totally okay answers. When you go back, the only numbers that you actually could not have had in this equation, by the way, is x should not have been 6 and x should not have been negative 1, because that's what makes these denominators 0. Okay. And this one, x should not be negative 3 and x should not be 6. Remember when we were looking for domains of rational functions in chapter 1? In other words, what is it that we can even have for an x? Well, with fractions, you want to make sure that you do not have quantities that would make your denominator equal to 0. So whatever x is, just make sure you're not substituting in a value that would make the denominator equal to 0. So again, this trinomial here factors exactly into your x minus 6 and your x plus 3, and that's exactly your LCD, these two factors. And that's going to come up every time. Well, at least for the kinds of problems that I'm giving you. Of course, it doesn't have to be. It could be extremely complicated, but that's not what I'm going to make or I'm going to give you. Okay. So here it is. Let's distribute. Multiply everything by these two parentheses. So again, the x plus 3 goes away, leaving you with a negative 1 and the x minus 6, the one this fraction didn't have. This one's going to leave you with a 2x plus 1 and the extra x plus 3. And when I multiply it to the last fraction, both factors will be gone, and therefore therefore we leave left with a 5. So again, distribute. We will end up with a quadratic equation. So hopefully by now you've done enough problems to where distributing should not be an issue anymore. Moving out through parentheses, we've done it in pretty much every chapter, really since chapter 1. Okay, so let's see what we can factor here, and this time we can factor out a greatest common factor of 2. And then think again about numbers that multiply to 2 and add to be 3, which are 1 and 2. So the two choices I have, the x is -1 and x is -2, and they're both acceptable answers. There are a couple in your homework they're not going to be acceptable. In other words, they're going to be one of those numbers that make your denominators equal to 0 that you had to exclude from the beginning, but that's not the case here. Okay, so again, here we should have excluded 4 and -4, and again 0.8 is none of those. Here we only exclude 0 and 2/3, and then the top two equations, all we had to exclude was a 0. So all these answers worked. All right.